Okay, guys, this is going to be a continuation of our series on how to graph. Previously, there's a video on how to plot points. So basically, you have to know how to plot points before we get deep into graphing linear functions. I should be more explicit, graphing linear equations, all right? Or linear functions, right? Linear functions. So in this case, you will have something like y equaling a linear function like mx plus b, or you'll have an equation that looks like ax in the form ax plus by equals c. And I will get more in depth with what this is in a series of video. I'm going to try to piecemeal this video so you're not overwhelmed, because when it comes to graphing, different types of questions will be coming at you. So what I want to do is do a video on how to attack each graph type linear function problem. And the first one I'm going to start with is finding the slope. Finding the slope of a line. And in order to find the slope of a line, you must be given 2 points. So you will give a point, you'll be given 1 point that will say, point 1. You'll have an x and a y, each coordinate has an x and a y. And point 2, you have another x, which will denote as x2 and y2. So you'll be given these 2 points, and they ask to find the slope, just to find the slope, no graphing at this point. And you will represent that by a formula. And that formula looks like this: y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. So either of these formula will work. Notice that you can interchange the y's and 2, but please pay attention. You can't have y1 minus y2 and then have x2 minus y1. If you're going to find a difference between y1 and y2, you have to find the difference between x1 and x2. Likewise, if you're going to find a difference between y2 and y1, must find a difference between x2 and y2. And let's understand what the slope is. The slope is, as we know, is called rise over run. Right? And if we just have a little snippet of our graph here, when we're talking about rise, we're talking about the y-axis, right? The y-axis goes up or down. And when we're talking about run, we're talking about the x-axis. So go in x direction. So when you're plotting your slope, you go y direction first, then x direction, right? Y direction over x direction, right? And of course, instead of saying rise over run, when it comes, if it's negative, then we could call it fall over run. I've never seen them use that in a math text, but fall over one if you're y for negative y. And like I said, it wouldn't matter if you choose to go up, down when you have a negative, or you can choose to go left or right. Okay, because this is one rational number, a negative will negate the entire thing. So you could choose whether you want to go up and go left, or whether you want to go down and go right. And we'll see that as more example come into play. So like I said, with this, finding the slope is really a plug and play. You must be given 2 points, and then you just evaluate those 2 points into either of this formula. And I'll do it both ways to show you that they work. So let's start with an example. So let's say we have 1 point equaling negative 1, 2, and we have another point equaling 3, negative 2. Okay, so let's give that a shot. Let's see what happens when we plug it in our formula. So I'm going to label it. I always advise students to label it, so you make sure that you substitute the correct letter. So here we go. So I'm going to try my y1, the difference between y1 and y2, x1 and x2 formula. So that is, I'm sorry, this is y1. So this is 2 minus, now notice x2 is a minus 2. So that's minus 2, y2, I'm sorry. And then it's going to be minus x1, which is 1, negative 1. I'm sorry, it's going to be x1, which is negative 1, minus x2, which is 3. So I'm going to evaluate this. As we see, this is saying the opposite of negative 2, which is positive. These are two negative terms, so I'm going to add and keep the sign. So this is saying 4 over negative 4, which yields out to a wonderful constant of negative 1. So my slope, which I forgot to mention, is also represented with the letter M. The slope is also represented with the letter M. So this formula is really saying that M equals, okay? The slope is represented with the letter M. All right. So let's try the other formula just for you possible doubters. Let's try the difference between y2, y1, and x2, x1 to see if we yield the same answer. So I'm going to try with the difference between y2 and y1. So that's minus 2 over x2 is 3 minus 1, right? Because remember, the formula, it's a difference. We don't care about this minus out here. We care about what the value of the variable is. It represents what the letter represents. And right now, x1 is negative 1. So here we go, using the same rules of signs. I have two negative terms, so I'll add, keep the sign. And here we can see that this is saying the opposite of negative 1, which is positive. So I'll just cut to the chase, and that's 4. As you can see, when we're dealing with factors with unlike sign, the answer yields a negative 1. Wonderful. Guys, basically that's all there is to finding the slope, that you must be given 2 points, right? And you must know this formula. So usually formulas are not going to be given on exams. You will have to memorize the formula, and then you just make sure you label your points and substitute the values. Let's do one more. Let's just do one more just to get you comfortable. Maybe you can try it with me. So let's say I have 2 points, 2, 5, and I have another point, 0, negative 3. Okay, so I'll label my point, and I'll use any formula. By default, I always use the first formula, just by default, not by no particular set of rule. So I'm going to find the difference between y1 and y2. So that's 5 minus 3 over 2 minus 0. That's 5 plus 3 over 2. That's 8 over 2, which is 4. And, just in case you tried a different way, you might have gotten an incorrect answer while trying it with me. Let me just do the other way. Let me just find the difference between y2 and y1, x2 and x1. So here we go. So it's y2 is negative 3 minus y1, which is 5. And x2 is 0 minus 2. So here we have terms with like signs, so that's yields a negative 8. And that's a negative 2, right? Because 0 minus 2 is still minus 2. And here we have positive 4. So we have the same answers. Check, check. All right, we're going to move on to the next.